Yes, sir. Yes, sir.
Yeah, thank you. Yes. Warm greetings to all. This is Dr. Hariswaran, Assistant Professor, Department of Civil Engineering. I'm happy to welcome you all for a session on innovation in ground improvement techniques. It's one of the session in faculty development program on emerging trends in civil engineering. So I would like to thank the opportunity given by the department, coordinator, and management for delivering this session. So let us get into the topic. So what are the things I'm going to cover here represent in a short slide. So what, why, how, need of the ground improvement technique. So what is the purpose of ground improvement technique? First, I'm going to narrate. Then why it is needed. Then how this can be executed in the field. Actually, what is the application and what is the final need of the ground improvement technique? I'm going to discuss in this short presentation of 1.5 hours. So there are different construction materials available, such as steel, concrete, brick, stone, timber, etc., etc., etc. Many of the time we miss one of the most important material is called a soil. But soil also one of the construction material we are supposed to consider. Like other materials, called concrete, steel, bricks, and everything are manufactured artificially with the available materials. Then there is a well defined calculations and design everything. Through this we are getting a desired strength and stiffness. On the whole we are able to monitor the quality, but in case of the soil, it is naturally occurred. The properties are mostly not known, depends on many other factors we are supposed to consider. There is no control over its quality. So why it is we can't able to exactly quantify the quality just by observing or by visualizing, like that means it depends on a number of factors. So first of all, everybody aware regarding the formation of earth. So we are having a different layers of the earth from the inner core and mantle, and at the last layer we are having is called the crustal layer. So due to the changes in the pressure and the temperature, the molten liquid which is present inside the earth try to come out and reach the surface and solidifies. So there are different type of formation of the rock or substances. Technically we are calling it as igneous rocks. It may be the molten material, it's maybe reach the outside the surface. We are calling it as a exterior igneous rocks. This may be some type of layer. It will never allow that molten liquid to reach the surface. So that at the time the molten liquid solidified inside the crustal layer, so that we are calling it as a interior igneous rocks. Then based on the external actions, the change in temperature, change in pressure, and all the aspect, that rock surface is going to get weathered, and that weathered things is maybe undergo erosion. Then everything is transported from one place to the another place. It going to the repeated deposition, forming a new type of rock. During that process you can see sediments are keep on depositing, and a process called cementation, because of only pressure or because of the mixing of natural solution. A cementation will occur, that repeated formation, a new type of rocks got evolved called sedimentary. Apart from these two, there is another type of rock is called metamorphic. This happened, already formed rock undergoes some changes in the aspect of structural changes or mineral orientation changes or group changes. A new type of rocks got evolved called, that is called metamorphic rock. All rock may undergo once again, it undergo, this is called rock cycle. So here whatever the material we are having at the surface may be of rock or maybe of soil. How that soil got evolved means only because of weathering of the top surface of the rock is a final product, that is called as a soil. That soil may be of two types. Extremely we are categorizing cohesion less soil and cohesive soil. The question less is nothing but sandy soil. It is formed or it's arrived by the alluvial deposit. Due to the running water, all parts of the rock is going to disintegrated, and finally it travel for a longer distance, and finally are deposited at the river basin. We are taking that as a raw material for construction, river sand. Then another type of soil is called clay. That happened because of chemical weathering. The rock surface is going to have a contact with the natural atmospheric air, natural humidity, the natural air, then whatever the liquid or gases in and present of it have a contact with that, and finally a rock layer is going to get deteriorated and keep on deposit. We are getting another extreme type of called cohesive soil called clay. So the characteristics of the sand and clay is purely depends on parent rock like igneous, metamorphic, and sedimentary. The characteristics of these things purely depends on magma. What type of materials got melted, and how what type of minerals is dominant. Based on that only we are able to confirm the characteristics. That is why the soil present in two different places cannot be having a same characteristics. Maybe look like the same, but characteristics may not be same. The probability of matching is somewhat very less, 50% we can say. Then another thing is called water cycle. Everybody aware on this. Due to the temperature, water is going to get evaporated, cloud formation. Because of temperature and pressure and temperature, clouds are moves towards the landy region. Then because of different process, that clouds may get precipitated to the water. That water may be strike the high mountain, and then the water may be started to run. There are different possibilities. This is also a circulation of water cycle. The water, the behavior of the soil is very good if it is only in a normal condition or natural condition. Whenever there is an interaction with the water, particularly flowing water or running water or seeping water, the characteristics is never be same. That end result may be purely more dangerous. So that is why we are supposed to undergo or understand or execute a ground improvement technique at the field to enhance the properties. We can see nowadays, because of more urbanization, you can refer a map of our Chennai long 10 years back or 20 years back or 4 to 5 decades back. That occupations of people is very less nowadays. Because of urbanizations, we are all forced to utilize the land, but unfortunately the land is not capable, may not be capable to take that much load at the time. Our intention is to supposed to execute such structures. Then there is no other go, we are supposed to improve the performance of the soil to achieve our goal. So that is a need of ground improvement techniques in our civil engineering. So there are a number of type of structure we are supposed to challenging structures, commercial buildings, high rise office buildings, highways, railways, tunnels, earth dams, etc. Everybody aware regarding underground tunnel inside the Chennai. In most in few part of our metro routes is purely underground. Executing such type of creating a hole and constructing such type of concrete element is not at all easy. So before executing that, n number of soil investigation supposed to be carried. Then only with the help of TBM, tunnel boring machine, we are executing everything. But a geotechnical characteristics and enhancement of the soil along the path prior to the execution of the tunnel is much mandatory. So this is how the need of the ground improvement technique plays a major role. There are different type of natural soil available on the surface of the earth, maybe of soft clay, silt, organic soil. Each type of soil have a different characteristics. If you're talking about soft clay, most of the Chennai region is of a top layer up to call 4 to 5 meters. We can expect a soft clay. Constructing a structure on the soft clay is easy, but a durability and performance of a building element will be very weak. Even a normal contractor, without going for any calculation, with the help of thumb rule, they can execute a structure on the soft clay. A structure will be more stable, but the problem will be reflect after 1 year or 2 year, after 3 year. It depends on type of soil and how much probability of action of the water with such soil will decide that. Even a newly constructed home, it will never show any form of failures like a cracks or differential settlement. Nothing will be visible. After 3 years, you are able to visualize what is the actual problem. The most of the problem we are facing is called differential settlement. A crack will be propagated from the wall towards top. So that is the most important sign. We have to take care some repair work to avoid a future problem. A soft soil will have a low strength. It have possibilities of high compressibility, low creep deformation, low permeability. Then while talking about silt, it's around the dimension we are categorizing as per Indian standard. A size of up to 4.75, we are calling it as a sand, from 2 mm to 4.75. Then 75 micron to 2 micron, we are calling it as a silt. Less than 2 micron, we are categorizing as a clay. So here, while talking about a silt, it it will be exactly placed in between the characteristics of the clay and the sand. It have low bearing capacity, high compressibility. There is a more chance for liquefaction potential. Permeability also low. There is a more possibilities of erodibility. Then an organic soil, the presence of some organic content, it have a high compressible, low probability. Next is called a loose sand. A sand that is to be compacted in a right way, then we can call it as a closely articulated structure. A contact with the nearby structure is higher, we can call it as a dense. But in naturally available, there may be the condition of the loose sand. For that case, the strength will be very less. For a most dangerous thing is called as like that of silt, a loose sand also having a high liquefaction potential, right? As having very large voids or interconnecting voids, the probabilities of for permeability also high, erodibility also high. The next type of problem is called expansive clay, right? Soft clay have a more chance for it going to undergo compress, it undergo more settlement. But expansive soil create a most dangerous thing. There will be a more volume change, it may get expand, it may swell when it have a contact with the water. After drying, it may undergo shrink. So these two extreme condition exactly affect the foundation element. Ultimately, all the superstructure, it may face a problem because of the nature of the expansive soil. In Chennai, most of the area having expansive soil at top layers, then loses like that of loose sand, right? Next, there are different type of fills we are using on the surface of the earth for the purpose of artificially we are filling and utilizing to achieving sustainable goals. There may be some type of uncontrolled fill. There will be nothing will be segregated without knowing any properties. We are using such type of fill, uncontrolled fill. Then dredged material, reclaimed fill, recycled material, solid waste, biomass byproduct. Those are the different type of fill we are using. When we are using that type of fill at the construction site, we are supposed to undergo a proper test. Then only we have to execute. So what is the problem we are facing at this real time case? First one is called bearing failure. The superstructure will be very good. It was designed with taking care of all live load and dead load, and it have a more capability to transfer the bending moments or towards support, vertical support called column. But only the problem is footing also very good. But whereas why such type of building is going to get fail means the applied pressure is higher than the ultimate bearing capacity of the soil. So that is why the importance of the site investigation. Before you going for constructions, you are supposed to undergo a soil test at the field, and you have to arrive what is the bearing capacity. That is safe bearing capacity, we are calling it as SBC. Then whatever the pressure we are transferring, that pressure should not be higher than that of capability, that safe bearing capacity. If it exits, automatically the soil may be failed in the form of bulging or lateral movement or compression. Any shear failure may occur. So this may be due to the high applied pressure, inclined load, small loading area, low soil strength. The next is called large total and differential settlement. If we are going to construct a structure, we are always expecting the subsoil must have the uniform thickness of same type of soil. But in existence, it is not easy to achieve such type of homogeneous soil. If a particular part of the building having a clay, soft clay or expansive clay, or another remaining part of the building may have a good material like rocky or sandy soil, then the behavior is going to get differ. The load distribution also going to get big differ. So ultimately, we are going to face a differential settlement, right? Particle rearrangement, it's purely depends on Hooke's law. That is, up to a particular limit of the loading, we are expecting load is proportional to the stress is proportional to strain. If it is an elastic limit, no issue. The load will be, if we are removed, it may be come back to the original position. The stress may be relieved. So this happens only because of a general high applied load, high compressible soil, particularly non-uniform soil. That is the problem we are facing. Next is called ground heave. This is also a problem. As I mentioned earlier, whenever the soil have the chance for contact with the water, there may be chance for swelling. You may, as an engineer, we may face n number of areas at the ground floor. Once the material is called dumped, we are going for a flooring. If you are going for any tiles works, after 4 to 5 years, you can see some undulations of tiles work. This happened. The below ground is got heave because of having a contact with the water. That swelling pressure we are supposed to consider. The pressure whatever coming up is higher than that of whatever the pressure we are applying downward, then only we can expect this type of heave. This may be due to the presence of expansive soil, action of the water, in extreme case frozen. Why we are mentioning the frozen means a liquid may percolate inside the voids of the soil. In extreme condition of negative, the soil may undergo a freeze. Whenever the soil undergo freeze, the volume is going to get increases. Once again, if we are getting a normal temperature, all things going to get once again it going to get solute. It going to come back to the liquid form. The process is repeated. Ultimately, the overall volume of the soil is going to get increases. Finally, we can achieve this type of heave. Next is called, the next type of geotechnical problem we are repeatedly facing in a hilly region is called slope instability, right? The whatever the slope we are constructing, that is to be designed with good factor of safety, at least more than one, right? Whatever the stress strength it have, divided by whatever the stress what we have applied. This ratio we are calling it as a factor of safety. The strength is always must be higher than that of the stress we have applied. But unfortunately, the strength of the soil is going to get reduces during the rainy season, right? The numerator is going to get reduced due to accumulation of the water inside the soil. The denominator is going to get increases. So automatically, the factor of safety is going to get less than one. Finally, a collapse of a slope is going to get occur. So to throw away that, we are supposed to plan for a proper drainage work, a proper execution of the work, a proper compaction we are supposed to execute. Then we no need to worry regarding that. Only the thing, the shear stress is higher than that of the shear strength of the soil, right? Then the most problematic thing is called liquefaction. It is one of the problem which occur mostly during the phase of earthquake. If the soil, if the construction is executed above the presence of a loosely packed soil, right? The attached picture will help you to understand. Uh, Below this, there is a presence of hard stratum, no issue. But above that, there is a presence of some loosely packed soil, right? Initially, if it is in a compact condition, that is more capable to take care of the superstructure load. So that structure got executed. But we are supposed to think about the possibilities of liquefaction, whether such structure is capable to take care of such liquefaction or not. So what is liquefaction? We are categorizing as stress takes place in a soil in the three way. One is a total stress, one is effective stress, another is called pore water pressure, right? The sum of pore water pressure and effective stress is called total stress. Whenever there is a presence of water inside the soil, and due to the earthquake, the water table is trying to move upward. So because of the movement, the water particles keep on travel along the pores of the soil, and ultimately the pore pressure is going to get increases. Effective stress is going to get reduces. Effective stress is nothing but a contact stress, a stress taken by soil. When there is no contact of nearby particle, the effective stress is zero. So that is what, when effective stress becomes zero due to the increase of pore water pressure, a condition called liquefaction will occur. So this is have a more probability to happen if the construction site consists of a loose silt or loose sand. Also, this is most predominantly occur if there is a presence of water table near to the structure. Because of dynamic motion, the water table try to move upward. Then only this type of liquefaction will occur, right? Then it's called erosion, removal of soil particles because of the running water. Every soil particles have some shear strength, interlocking strength. When a water flows above such type of soil, the strength can be mobilized higher than that of strength. Automatically some type of soil may run away along with the water. So this is, we are calling it as a erosion. If it Erosion is not happening only one time. Initially the impact is very less. When if it is happening continuously, a large loss of soil create major soil compression and leads to the differential settlement of the structure which is constructed above that, if the same thing happens to the structure which is constructed near to that. So the erosion control must be properly identified. This happens whenever there is a hydraulic activity is there, water, running water, stagnant of water, retaining of water. So in those aspect, we have to think about proper drainage, right? Next is called seepage. Everybody aware regarding the Darcy law. V is directly proportional to I. V is equal to Ki. Then Q. Discharge is equal to Kia. Everybody aware, based on the basic understanding of civil engineering, particularly in soil mechanics subject. So when we are going to get a seepage means when there is a difference in head. Water is always move from water is always wanted to be in equilibrium condition at static condition. But intentionally we are increasing the water table in a dams or in a stagnant area or overhead tank, everything. Once rain got accumulated, scattering of water over the surface, water is always find the shortest route to reach the static condition, right? So like this type of seepage occur when water is retained behind the dams. Water is always try to escape. It is always under some pressure. It always find a path to escape. So such type of the movement we are calling it as a seepage. So when we are planning for any retaining structure like dam or retaining wall or sheet pile, a property called seepage we are supposed to execute, and we have to give the solution for that. So now let us come into the exact. So as of now we come to know why this type of ground improvement is needed. Now let us discuss about how this can be achieved. So there are different ground improvement technique is there. The first thing is called dewatering. If you are removing the water, automatically the soil particles have a good contact. This can be achieved. Then electro osmosis method, that is also removal of water. excavation and replacement, geotextile enhanced column. This a typo error. This is geo, not SEO. Geosynthetic reinforcement, intelligent compaction, mechanical stabilization, reuse of waste material. Incorporating these things inside the soil, we can improve. Then aggregate columns, sand column or stone columns, like that we can. Then bio treatment of our subgrade, blasting densification, then chemical grouting, deep dynamic compaction, then grouting, soil nailing. So this is predominantly we are using. This is a most intelligent technique. We can say now most of the area, whenever we are going for underground construction, for any other mining work or any other applications, we are always going for a soil nailing. Just we are penetrating a steel rod with having the capability to take care of higher tension. So that is called drill or grouted or soil nailing work. Then mechanically stabilized earth wall system is nothing but the soil is properly compacted, then each layer is executed with high dense the things we are calling it as mechanically stabilized earth wall system. Then deep mixing, uh, by creating a hole for a deeper depth by incorporating some type of a lime or chemical or something, by injecting in that we are making that whole region is going to behave like a hot stratum. Then PVD, prefabricated vertical drain. This also plays a major role in case of geotechnical ground improvement area. It is nothing but removal of water from the uh, soil. That to clay soil is very challenging. The clay have a capability to retain the water inside the pores, but it doesn't have the property to transfer the water or allow the water to seep inside. So that is the problem. But that water can be taken out under the application of the load, right? So let me explain regarding a consolidation later. So this type of prefabricated vertical drain will help us to achieving a proper removal of water from the compacted ground. Next is called rapid impact compaction. It is one of the type of compaction. That is the topic I'm going to discuss here in a further slides. Then reinforced soil slope. The soil may be reinforced with a naturally available or artificial available material like steel, like bamboos, or aluminum, or concrete slabs or concrete bars, a pre-stressed materials, anywhere. If you are reinforcing inside the soil, we are calling it as a reinforced soil slope. Then sand compaction pile. Another is called vacuum pre-loading, right? Next, vibro compaction. Vibro compaction I'm going to discuss here in the further slides, right? So preloading technique is nothing but in most area of in Chennai, in and around Chennai, most of the area is of clay region, clay soil. If you are going to plan for construction of high rise building or industrial building, we are supposed to uh, apply very large loading on that, but the soil is not capable to take the load. Maybe that can be stabilized by incorporating sand pile or stone pile or any other pile foundation, we can achieve it. But the problem is a saturated clay, when we are apply the load, it may slowly undergo consolidation. That removal of water is from the voids going to happen. So that preloading technique to nullify this problem. For example, if a soil is in a particular area, we are going to construct a structure that may transfer some amount of stress. The same stress can be predefined and that can be applied before the construction itself, like placing very large concrete blocks over the soil. That load automatically slowly compress the soil because of the applied static load. Based on the stress we have applied, the water present inside the voids of the clay slowly dissipate outside. The process is, we are calling it as a consolidation. The consolidation depends on a number of parameters called permeability of the soil, size of the soil particles, and coefficient of permeability we can technically call. then what, how much intensity of the load we are applying, then how much time it takes to get 100% consolidation. It depends on n number of factors. So that vacuum preloading, applying the preload and applying the suction pressure to remove that water, this technique will be the very good solution, but only the problem is time consuming, right? Here the most important ground improvement technique, so whatever the type of technique whatever I have highlighted is, it's purely based on a soil interlocking properties. Ultimately the soil density we are going to improve, the denseness of the soil we are going to get improve. So a compaction plays a major role. So I am going to, in this a short speech, I can't cover all ground improvement techniques. Now I am going to concentrate on a topic called compaction. What are the different techniques available for achieving the compaction? Then what is meant by compaction? How to differentiate a term called compaction and consolidation? What are the different type of compaction techniques? So these are the things we are going to discuss in detail in a further discussion. So what is mean by compaction? A picture is replicated two times. So now you can see here expansion, compaction is nothing but expulsion of air from the voids under a dynamic load is called as compaction. So when we are taking some amount of soil in our hand, there is a chance for existence of three phases. One is soil solid, another is voids. That voids may be occupied by water or air, or fully by water or fully by air. So ultimately three phase going to get takes place in the soil mass. One is soil solid, another air and water present in a voids, right? That voids may be fully occupied by water, voids may be fully occupied by air. So based on that we are categorizing in a three way of soil. If the voids is fully occupied by air, there is no presence of water, that condition we are calling it as a dry soil. If all the void space is occupied by water, then we are calling it as fully saturated soil, right? If the void is occupied by both the phases, like air as well as water, then we are calling it as a partially saturated soil, right? So now, what is compaction is nothing but removal of air from the voids under dynamic load is called as compaction. It is not easy to remove the air present in a void just by applying a static. A 10 kg load applied on the ground surface is just 10 kg, but the same 10 kg may be lifted for 1 meter and leave that, then it creates impact. That impact energy is transferred to the soil. Automatically the soil particles may be reoriented, some amount of air particles may be expelled out. So that is called dynamic. There is a two differences there, dynamic force and static force. So compaction is only applicable for dynamic load, it cannot be removed by a static load. We have to provide any type of force, maybe dynamic or else at least kneading, right? Like we are preparing chapati by kneading the materials, by raw materials, with the help of our fingers we are kneading. So automatically it provides good mixture as well as compacting the material. The same, at least we have to go for a dynamic or kneading action, right? So next is called how this can be achieved. There are different methods available in the laboratory for achieving, as well as field also which is available. So what is a role of compaction or conducting the test on compaction on the particles means? It plays a typical role. If you are going to construct a road, if it is a normal flexible payment, we are supposed to going for a 4 layers, starting from subgrade, base, subbase, and final topmost layer is called a wearing course. So each layer we are undergoing compaction. If the compaction is not uniform, is not completely achieved, ultimately the performance is going to get affected. If any roads are constructed in a very short term without proper compaction, within a 2 to 3 months, because of repeated movement of vehicles or repeated loading, automatically we can see more undulation on the surface of the wearing course or a bitumen layer. This has happened because the underlying soil is got compacted because of repeated load. So to replicate that, we are well defined, well planned how much energy is going to transfer. We are compact the soil while the construction itself. So that is what subgrade. Right? To compact it, we are supposed to remove a maximum amount of air from the soil. But we not at all able to remove 100% air from the voids. There will be some existence. So that existence or that probability can be found from the laboratory by executing Proctor compaction test and modified Proctor compaction test, right? In a mold, we are applying the load and we are arriving standard energy we are applying, and what is the density got achieved for applied energy for added water percentage, and then we are changing the water content. For a particular water content addition, we may get maximum density. So that we are calling it, that condition or that water content, we are calling it as a optimum dosage of soil or optimum water content, OMC we are saying. Corresponding dry density, we are calling it as a maximum dry density of the soil. The same, we are using the maximum dry density to achieve that maximum dry density. What is the optimum water content? That percentage we are applying on the road surface when we are compact the road subgrades or base or subbase. So that amount of percentage, this may be 12 percentage, 14, 15, it depends on type of soil present over that area. That percentage will be arrived from the laboratory test. So that let me explain once again later. So now, what is the effect of compaction? So now we are executing the compaction. What is the end result? So compaction exactly increases the density. Density is nothing but mass by volume. Because of repeated energy on a known volume of the soil, sorry, known mass of the soil, volume no, mass is not going to get changed, only the volume going to get reduced. Density is nothing but mass by volume. When denominator decreases, automatically the density is going to get increases. Our intention is to increase the density, that closeness of the particles. Next is called strength. Density is directly proportional to shear strength. Automatically strength characteristics also enhances. Then load bearing capacity. If the loose soil have a capability to take some stress, then after compaction, the load carrying capacity is also get increases, right? Then we can reduce the undesirable settlement. A loose soil may undergo more settlement once it got compacted for a required for a maximum possible, then automatically we can avoid such type of settlement. So each type of construction, like residential as well as whatever may be, a surface to be level, then we are supposed to go for proper compaction. We should not worry regard the expenditure we are that is involved in that activity. If we are compact the whole surface of the area of the construction, we no need to worry regarding the future settlement or future problem. Then increasing the stability of the slopes and embankment. One of the important construction in with the help of soil is called embankment. Particularly in case of highways and railways, we are using this type of embankment. Also in case of constructing a small scale dam or earthen dam and at all, that is providing or elevating the level artificially by dumping the soil mass in a repeated layer, providing a slopes in both direction is called embankment. Such type of embankment have the problem of slope stability. The sides is always somewhat having some inclination. That inclination we cannot give a very steep manner. Also, we cannot give a very light slope. If you are providing a very light slope, it occupy more area in both sides of the embankment. But the cost of the area is very much higher. Our ultimate aim of each engineer is always to provide economic solution and safe solution. So we cannot able to provide a very steep slope. The soil does not have a capability to stand in a vertical manner. So steep slope also we can say somewhat tedious or dangerous. So by compacting the soil, we can achieve somewhat increase in stability of the slope. Right. Next, to decrease the permeability. Automatically, that application of the load or application of the dynamic energy, the reorientation of the particles, the size of the pores is going to get reduced. If size is got reduced, automatically the flow of the particle is going to get reduced. But only the thing, one more thing we have to keep in mind: a permeability is not directly proportional to size of the particles. It directly proportional to interconnecting voids. For example, if you are having a gravel, in case if you are in a container, we are having a gravel, in another container we are having a sand, in another container we are having a clay. In which type of soil the water will be flow easily means, in case of gravel, the size of the void is higher, interconnecting also possible. But in case of the clay, the size of the voids is lesser, the interconnectivity also somewhat tough, so the flow will be very very least. Somewhat we are calling it as a clay is a impermeable. But another criteria is there, in which case voids will be higher, that is volume of voids is higher. Everybody will have a myth that a gravel have a more volume of voids. Actually not. Gravel have a very large size, but number of such type of voids is lesser. So if you are adding all volume of voids, it have some value, that is x. But in case of the clay, the size of the voids is very small, volume is small, but number of voids in a clay is, numbers will be millions. So if you are putting adding together, we are getting a value. Y is a volume. The volume of voids in a clay is always higher than that of gravel. That is void ratio, volume of voids to the volume of solid. Void ratio is always maximum in case of the clay compared to the gravel case, right? So that is why the compaction imparts reduction in permeability. Then automatically the size of the voids is reduced, the seepage potential also reduces, it also reduces the possibilities of shrinkage and swelling as well as frost, right? You just have a look on this picture. Yes, here this picture exactly demonstrate the differentiation between compaction and consolidation, right? Compaction is nothing but reduction in air under dynamic load. Next, right side, another picture represent the reduction in volume of water under static load is called consolidation. So why not saturated soil can be applied with the dynamic load means it is not at all able to remove such type of water. Only top surface may take that dynamic load, and also it shows some changes. But the soil present or water present very deeper inside the clay soil never react with that dynamic load. So this can be removed only applying a constant pressure. Everybody aware regarding one of the world wonder, the leaning of Pisa Tower. So that leaning happens only because of a consolidation term. Below that tower, part of the area is occupied by high, dense, cohesionless soil. Another part is of clay soil, that too saturated soil. The soil behavior due to the sulfate of the structure, that presence of water inside the soil is slowly dissipating outside. Till now, the consolidation is not reaching 100 percentage. So that consolidation purely depends on the size of the particles. The time of 100% consolidation may differ from soil to soil. If in a clay soil you can practice, or you have a if you are in a teaching community, you can practice in the laboratory. If you are taking a wet soil sample, above that you can apply any constant load or 1 kg. Immediately once you have applied load, you can't able to see any change in the compression. You just observe after a 1 day, then after a week, after a month, after repeatedly, if you keep on observing, due to the applied load, the thickness of the soil is slowly reducing by dissipating water from the soil. 1 day, after maybe a several months or several days, that change in volume is going to get ceased. That condition is called 100 percentage consolidation is occur. Once again, that 1 kg may be increased to 5 kg. Once again, this process is continuous. So this consolidation is purely depends on how much load we are applying on the structure. So that is why it depends on different factors. Now the compaction, you can see we are conducting a proctor standard proctor compaction test. For each, the x-axis shows the water content, y-axis shows the dry density. For each case, we are getting a density. If we are keep on increasing the density, increasing the water content, we are the density also keep on increases. But after a certain increase in water content, the density started to decrease. So why this happens means the water present we are adding into the soil will help us to lubricate the soil particles. When we are applying the load, the soil particles try to have a contact with each other. If you are adding good amount of water, that water may be fill or occupy the surface of the soil particle. It will help as a lubrication. When there is a more lubrication, that more compactness we can achieve. But after certain limit of adding of water, if you are increasing that water, it replaces the soil. It will occupy, water started to occupy more, automatically that weight of the soil for a known volume is going to get reduced, automatically dry density is going to get reduced. So for a particular soil, this OMC and dry unit weight may be vary for soil to soil, condition to condition. So we are supposed to execute this type of test in the laboratory. We have to arrive what is the optimum moisture content and corresponding maximum dry density. The same can be recommended for a field condition to achieve a proper good compaction. So a different factor is called what is the water content available in a natural soil, then what is the amount of compaction we are providing, then what method we are applying the compaction, then what is the type of soil we are executing the compaction, then if there is any additional admixtures we are adding. So these are different factors will affect the end result of the compaction. Now we are getting into the main part of this part is called different type of compaction. The first thing is called excavation and replacement. Next, shallow densification, deep dynamic densification, then rapid impact compaction, then vibro compaction. So these are the different types of compaction technique available in a geotechnical engineering. So the most simple thing is called, if you know what is the load is going to get transfer on the foundation. If we are going for a small scale building, you know the width of the foundation as per significant depth, maximum of 2 to 3 times the width of the foundation. Up to that depth, the influence will be there. The influence of load transfer will never be for a larger depth, only for a particular depth. The depth may be exactly from the base of the footing. That influence may be up to 2 to 3 times the width of the footing. So if that region having a good type of soil, we can no need to worry regarding the performance of a structure. So this excavation and replacement, you come to know that soil have a weak, doesn't have a shear strength, low shear strength, that chance for expansion, chance for liquefaction. So if you know, if you just found that a particular region of the soil can be removed and a good material can be dumped there, with the proper compaction, we can achieve the end result, a proper distribution of the load, and we can achieve the end result of good things. Improving shallow problematic geometrically, it includes uncontrolled fill, loose sand, silt, sand, expansive soil, liquefiable soil, whatever may be. The excessive deformation can be reduced by this method of excavation and replacement. The area over excavation is limited. We can't able to go for a larger area. This can be limited only up to 3 meter, not more than 3 meter, because excavating the soil more than 3 meter, we required lateral support or shoring or everything. We are need a lateral support to execute. So it is restricted to 3 meter. So no or limited temporary shoring and dewatering is required for this case. No existing structure should be there near to that area. Otherwise, when we are going for excavation, the lateral pressure which is executed from the structure may be get exceeded. Ultimately, that excavation also get collapsed. The nearby structure also started to lean, or it leads to the differential settlement. That is a major problem. We are supposed to take care in a right way. Even if you are residing in a particular area, near to that, if any a new type of structure is there, they plan to execute in G minus 2 or G minus 3, the more care to be given. If they are supposed to provide support, then only they have to excavate the soil. Otherwise, a lateral mobilization of the soil create a destruction of our own building. So we are supposed to more give a more care when there is such type of excavation takes place in and around region, around our area. The removed soil can be utilized. Nowadays, the cost of actual soil, removed soil, waste soil have also have some values. A fill material is readily available that can be utilized. The advantage: increase the capacity, reduce settlement, eliminate expansion. We can avoid freeze the cost effective, simple and reliable. Does not require big equipments to execute this type of excavation and replacement methods. Next type of method is called shallow densification. Now I would like to densify soil for a limited depth up to 3 meter. For that, I can execute some type of artificial methods for achieving such densification. In soil mechanics, shallow densification or compaction means press the soil particles tightly together, expelling air from the void spaces. Indirectly, we are reducing the void ratio. Consolidation also reduction and results in reduction in void ratio, but consolidation and compaction is exactly not same. That is what I just highlighted in previous slides. The compaction is instantaneous and consolidation is slow. We can achieve the compaction immediately once we apply the dynamic load. But consolidation, we are supposed to wait. We must supposed to have a patient to get a end results after some known or unknown duration. The saturation is the essential condition for consolidation, which is not for compaction. There are different type of shallow densification that I have narrated here: a smooth wheel roller, sheep foot roller, pneumatic tire roller. Sorry, my connection is my share screen is visible. Also, am I audible? Sorry, due to internet disconnection, I just came out, and once again I just logged in. The hope I am my shared slide is visible. Also, I am audible. So this type of a smooth wheel roller, you may noticed to compact the subgrade soil. This type of smooth wheel roller mostly recommended for cohesion-less soil as well as cohesive soil. But the soil having appropriate cohesion-less soil, this type of a smooth wheel roller is recommended. This type of compaction, we are supposed to minimum of 4 to 5 times a roller, a load to be travel along that surface, then only we can achieve a top surface compaction. This may be shoot for a thickness of 200 to 300 thickness to compact it. This can be good. This is appropriate for subgrade or base course compaction of well graded sand gravel mixture. So well graded is nothing. There are two types of not two types. There are different types of grading of soil is available. The first foremost thing is called well graded soil. It consists of all size of aggregates. The people is always looking for well graded gravel or well graded material for this type of subgrade. So why means a large size aggregate have a when 4 to 5 gravels are there, there is a white space will be there. That white space may be occupied by sandy particles. A number of sand particles have a voids that may be occupied by silt. In between the silt particle, clay may occupy. So on the whole, the probability for natural void will be lesser. That because of presence of soil material much higher, the denseness will be higher. So always, if you are having a well graded, that will be good. The poorly graded is nothing but a same size of soil occupied in a particular volume. So whatever the compaction if we are giving, we can't able to relocate and everything. So that some amount of volume of voids is always there. It not at all able to remove that. So that is a problem of poorly graded. The best example is called beach soil. So when whoever walked over the beach, even though number of people repeatedly walking over that soil, we cannot able to make the soil is fully compact. So that is poorly graded or uniformly graded. Another type is called gap graded. Gap graded soil is nothing but it may have a sandy a gravel soil, and there will be absence of in between size of the particles. In extreme size, clay may present. So that is called gap. Some size of the particle is missing, right? So here we are always expecting a good well graded soil is there. This type of smooth wheel roller will be recommended. Next is a sheep foot roller. This will be recommended for fine grain soil. It's more than having a 20 percentage fine. We can expect this type of a smooth wheel roller give a good performance, particularly in presence of clay layer at the top. This because of the projected sheep foot, like a shape like a sheep foot, that will compact the topmost layer of maximum of 150 by kneading action, not by dynamic action. By kneading action, we can achieve the good compaction. So a minimum number of passes is required 4 to 8. A number of passes I have highlighted may vary from vehicle to vehicle and soil to soil, but approximately we can categorize. Then pneumatic tired wheel, based on the tire pressure, we are going to compact. So this will be recommended when very less fines is there. Coarse grain soil is available. This type of pneumatic tire roller is much recommended. The uniform distribution pressure will help us to compact the soil in well manner. So this also required or recommended for compacting around 250 for coarse grain, 150 200 for having fine grain soils. Next type is called vibrating smooth drum roller. A drum roller having some eccentric weight. Because of that rotation of eccentric weight, it creates some additional vibration. That additional vibration help us to compact much well. That is, energy of compaction from this type of roller will be much higher, so that compaction expectation will be good. But only the thing is, this type of dynamic compaction is recommended only for coarse grain soil, not it is not purely recommended for clay soils, right? We can achieve that the compaction is around 200 to 300 of soil. Next, vibrately plate compactors. Maybe you may saw this type of plate vibrator for concreting also, for roof concreting. The people may use this type of compactor, but this one is a very good compactor before we are executing for construction of the residential structures. That whole area can be compacted to achieve the surface compaction, not full layer. Maximum of 200 to 250 of soil can be compacted well and good through this type of vibrating plate compactors. Next is called tampers. The tamper or rammer, this may be a manual as well as motorized. A small tamper, that the projected surface will be there, that can be lifted and drop it manually, or with the help of this type of motorized also we can achieve. This can be most recommended for backfill or inorganic soil at all. For compacting 100 to 150 this can be recommended. So next type of compaction is called deep dynamic compaction. The deep dynamic means we are in need of higher energy to compact that underlying soil. So for that, the main concept or principle behind is a very large weight is around 1 ton or 0.5 ton weight is lifted for a higher height, more than 10 meter or 20 meter. Then that weight is dropped. That dropped weight create a dynamic energy. That energy propagate some type of waves, as like that of P waves and S waves and Rayleigh waves. That energy will be propagate inside the ground also. So because of that energy, we can expect some type of subsidence on the ground surface. So that main concept, the here, the typically what type of soil this can be compacted means, this will be recommended for cohesion less soil, or soil having very lesser cohesion or clay product. A tamper may be of 5 to 10 weights, a drop may be 10 to 40 meters. The compaction may be achieved up to 10 meter. That is the things. Now, how many drop we have to give? What is the spacing of one drops to the another drop, and how many times we have to do this? What is the weight of this compactor? At what depth we are lifting and we are dropping? These are the different factors we have to consider for this type of achieving end product, end results, right? So that the height of free fall, number of drops, spacing, homogeneity, strength and permeability, and degree of saturation at all. So it improves the characteristics for a large area, the effective for loose and partially saturated soil. If it is a fully saturated soil, this type of that compaction is not give a 100% results. Can detect weak or loose area during operation, because when we are applying the same type of loading for a particular region, after moving for a certain distance horizontally, when we are executing the same energy, same height of drop, uh, now subsidence may be more than what we are expected initially means, then we come to know there is some weak layer present below that region. So indirectly we are able to assess or detect weak soil below this. The changes in a heterogeneous soil also we can indirectly predict. Not major equipment, only the one very large crane having a capability to lift tons of weight and drop it. The major disadvantages, there is a chance for miscoordination among the people who are working on the field and who is operating that equipment. So that we have to take care. So this is the picture replicating. This type of dynamic compaction is not recommended inside the residential building, because this waves, the Rayleigh waves, the horizontal wave travel in longitudinal direction along the surface, that may impact on the nearby structure, then that may leads to the collapse. So that should not be recommended. Then rapid impaction compaction, the same, a load will be repeatedly applied for many times, that we are calling it as a rapid. You can see this energy is delivered at a rate of 40 to 60 blows per minute, right? The foot of 5-meter diameter, 5 feet diameter, is maintained contact with the ground to allow eccentric and safe transfer of energy. The high degree of control allows the machine to be used in difficult location and for variety of application. You can see, yeah, same load, higher diameter, then but repeated energy is given in a particular area, make the soil to compacted in a good way. But this is recommended for cohesionless soil or slightly cohesive soil, right? So because of this repeated energy, that repeated spacing in and around region, automatically the in and around region is going to get compacted. Then that area can be utilized for higher or high level of construction. The last method is called vibro compaction. It is nothing but this will be recommended for a compaction of the soil for a larger depth. What we have to do is, first we have to create a hole, right? First we have to create a hole by through the jetting action of this type of probe. At the bottom water will be jetted. First we have to create a hole, then there is a provision of rotation of this probe. It have some eccentric weight, you can see here. It have eccentric weight. Because of eccentric weight, the rotation will never be with respect to center. It will be never be uniform. There is a centrifugal force will be there, so it will be rotate in all direction at the bottom. So that disturbance make the soil in and around region is going to get compacted. Now the diameter of the hole is going to get increases. Now that may be filled with any other naturally available material, like sand or stone or any other material. Whatever the construction we are executing, usually we are calling it as a sand column or stone column. So that is the end product of this. By providing or constructing n number of sand columns or stone column in and around region, the whole region is going to get stabilized. Then above that we can plan for construction of any type of structure. So that is the most outcome of this different uh, techniques of ground improvement. So with this, I stop my presentation. So if you have any queries, you can raise here. If you have any queries, uh, kindly unmute your mic and contact with me. Otherwise, you can drop your question in a chat box. Let me try to answer for it.